Hello everybody and welcome to this pre-recorded YouTube video. It's about noon, so I just said goodbye to you guys probably 15 or so minutes ago. For those who are not aware, we had internet problems, and though the internet is back up, it's too late for that, so today's lecture we're just going to go over the examples that I've uploaded to WebCampus. And we're going to be introducing object-oriented programming, classes, and function overloading. So, before we get started, if you just come to WebCampus and look here, you'll see that I've already uploaded these 3 CPP files for you to follow along with if you would like, as well as I've pre-uploaded these notes, which I won't be typing, but we will be following along with. Everything in here that you need to know for function overloading and object-oriented programming with classes are in these notes. And so go ahead and save these, and when it comes to studying for the test, you're going to want to reference this. It does look pretty long, but it's only because I've included almost full examples here, where you can almost just cut and paste these. These examples I'll pretty much be covering in today's video. So I have those pulled open and we will reference them. And so let's go ahead and get started with our example today. So before I said goodbye to you all on the stream, I was letting you guys know that with object-oriented programming, you guys have had some experience with this before. The first thing, and I hope most obvious thing, is with structs, in which we can create objects and define their structure in C++. But you also have experienced classes before when it comes to things like strings, vectors, and with in and out streams. So when you include fstream, and then somewhere in your main, you've used these things before. You've used a string s, you've used an if stream, infile, and you've used a vector, maybe it's a vector of ints, array. So these indeed are all, and notice that they're green, right? If I were to type int, which this is just a primitive type, notice that VS Code colors this as kind of this dull blue color. But when you type in an object of a class, we get kind of this turquoise color. So indeed, these are all classes, and you've used them before. So hopefully this won't be too scary for us as we begin to learn about object-oriented programming and how to use classes. So we will come back to function overloading today. Because we're so crammed for time, given that we've missed a Monday and we'll miss another Monday in the upcoming weeks, I am not going to spend very much time on this. But function overloading is very simple. Notice here, this is all the text that I think you guys need to know for function overloading. And so we will cover it in today's example. Now let's begin looking at object-oriented programming. Now this is a method of programming, and it is the most popular in today's coding world, in which we can package data and methods together. We call these things methods, but these are just like functions. They're exactly like functions that you've already learned how to code. But I will call them methods over and over and over again, and so just be aware that these are just functions. And so if we take a look at our struct, a struct that we've done before, you'll notice that the only thing that's in here is data. There's no functions in here. And so structs, in a way, are good just to package data. Structs are good just to package data. Now it's a general rule of thumb that is included in our notes here today, and we'll come to that later. But the moment that we start putting functions within these objects as well, then we're going to start using classes instead. Now, before we do that, let me just define this term data abstraction for you, because you'll hear it quite often. And what we do with data is it's a way to simplify our data types, in which we will hide all the features that the type shares. And so I offer here two examples. One, if we consider a generic car. In general, cars have four wheels. They have at least one door. They have seats. They have a wheel. They have pedals. And so, in fact, cars all share these things. And so it's almost not important for us to define these every time we make a car object, because we already know that cars have these things. So in a sense, we would hide these features from the user. But then we only consider the things about cars that are different, such as the type of engine that's in it. Is it a manual or is it an automatic car? You know, how many doors does it have? Is it a gas or an electric vehicle? Things like this. We can also consider another example with a bird, in which we all know birds fly. They have wings and they have feet. They have beaks and they have eyes. So we don't have to define these features every single time that we define a bird. And we can kind of hide these features from the user. But what will the user actually be paying attention to? The things that are different between these objects, such as the top speed, what does the bird eat, how big is this bird, how's this bird colored. So that's what data abstraction is, and this is the most important line here in this code, is which we hide all of the similar features of a data type. You can even type that there. So let's go ahead and begin talking about classes and structs. You already know structs, and you use strings, vectors, and f-streams, which is something that I already covered. And there's something very cool about this, at least for you guys, since you already know generally how structs work. Classes are identical to structs except for one thing. There's only one thing that they're different. And it's that structs have this thing called public access by default, and classes have private access by default. And so I define these here below, and we're going to move into our example in which I show you what these things mean. So, to begin, a public member, and let me just say, what is a member? A member is either a variable or a function that belongs to a class or a struct. So in our example here, I've defined this struct here called point2d, and I've included this s here at the end just to specify that this is a struct. And in fact, I will put these two things side by side, a class and a struct. And we'll put these just exactly like this. We'll put these things in here, so they almost look exactly alike. And we'll put here in our comments that classes are good to package data and methods, which are also functions. So the only difference is that these are the members. That's why I came to the screen here to show you that these are members. So int x is a member of struct point2ds, and int y is also a member of struct point2ds. And it's the same here with the x and y that are in the class point2dc. So these guys are members of these classes and structs. And so what's a public member? A public member is accessible to all things. And what is a private member? Well, this member is only accessible to the class. So let's go ahead and demonstrate that. Let's go ahead and come into main here. And let's go ahead and define two of our objects, just like we've always done before. So we can have a point2d s, and we'll call this p1 for point 1. And we can have a point2d c. We'll call this p2. So this is the struct And this is the class. And so how do we access elements within these objects? Well, we use the dot operator, right? We can go ahead and set some values into these x and y's. So I might say something like p1.x is equal to 3, and I might say something like p1.y is equal to 4. And so what is that point? Well, it's a geometric point, so we would consider it to be like this, right? In an xy plane. Now, this code will compile just fine. And we can even print out these things. And so I might say something like cout here, and we can do a fun little format thing here. And we can compile this and it's going to run. Since we are connected to Sally right now, hopefully, looks like we are, I will go ahead and bring this code into here and just compile it to remind you guys that everything is working just as expected. I know our resolution is not super high on the YouTube videos, not on the stream either, so I'm just going to make this as big as possible. So that looks like it's good. If I type ls, I should see it in there, except I am not in the correct folder. But now I type ls and I should see it in there. And here's my compile statement. So we'll go ahead and hit enter here. Everything looks good, and I /a.out that guy, and what do you know, we've got 3.4 right there. So now let's look at the class. I'm going to do the exact same thing with the class. Except we're going to do P2 instead. And let's go ahead and change up these numbers just so we can have this idea that these are different. And we'll go ahead and print out the P2s. Now recall that these guys are private members by default. And these guys are public members by default. And so now we're going to have a compiler problem. And I'll tell you exactly why. We cannot access x and y from main. I'll put a space here. Because x and y are private. And so what did I say in the notes here? If we come look at the notes, it says this member is only accessible to the class. Well, here we are in main, which is not the class. It's actually an outer scope. And we're trying to access x and y from main. So the compiler is going to say, hey, this is not allowed because x and y are private members, and only the class is allowed to mess with these members. So let me go ahead and save this. And I'll pull it into Sally, and I'll show you exactly what the compiler will tell us. So we see some pretty big errors here, right? You see exactly what it's pointing at. And it says error, x is private within this context. And it says, look, it's declared private here. So how can we change that? And what are our options now? So let's come look at the notes. And notice here that we can actually specify what we want the members to be. And this is, in fact, how structs and classes can be exactly the same. So actually, if I came in here and I typed private, then anything underneath these private members, or anything underneath this private, we call this an access modifier. Anything underneath this access modifier until the next access modifier is specified, such as public, will belong to this access modifier. So x and y, in this case, are private. But if I moved them under here and I say have something like int y, which would make this a 3D geometric point, now y will be public and accessible to things like main. but X and Y will not. So even if I save this code and I compile it again, not only will we get the exact same errors from the class, but now you'll see we get the same errors from the struct. So if we kind of scroll up all the way here, you'll notice that I did a redeclaration of point Y, which is not what I wanted to do. And I also want to just kind of comment this stuff out so we can really boil down to what our errors are looking like here. So I'll go ahead and pull that over there. Again, we'll type clear, and then we'll give it our best shot. And notice we get these same compiler errors that say, hey, point2ds now is private within this context. And so public members are accessible to everybody, and private members are only accessible from within the class. Now we'll talk about what that means shortly, but just as long as we now have this idea that structs are public access by default, meaning if no access specifier is typed out. And that also goes for the classes. And so in fact, we can come in here and fix all of our compiler errors by doing this. I'm going to comment this out. And let's just assume that this struct is exactly the way that we had it initially. And here in class, inside the class, I will type out public. And now that X and Y are underneath this public modifier, we should be able to access them using this code that I typed here. Once we compile our code here, we'll be able to move on. And we will see this public and private thing so much. Notice here that now we've compiled successfully, and I can /a.out, and we get our second point here, which is 4.7. So no problem at all. And as I was saying, we're going to see this public-private thing over and over and over again. Let's see what I've listed here. So as we come down here further in the notes, I define what a member is. And I even got this little example of a struct in which number of wheels is a member of this structure. Now I say, can we initialize members within the class or struct? Yes, let's go ahead and look at an example of that. Let's assume that I don't set these values here. In fact, I can just come up here and I can say something like is equal to 0 is equal to 0. And so now whenever we declare a point of a struct or of a class, we can initialize them to these values automatically, which is important to do because otherwise these X and Y variables will get some random location in memory and they will probably contain some garbage values. So notice here that we do some initialization here, and we should see that P1, X, and Y are 0, 0, now that we've initialized these members from within the object. Go ahead and compile that. Give it a good old run, /a.out. And you can see here that now this point is 0, 0. We initialize that nicely, and so always remember that we can do that. Now let's go ahead and look at these member functions, and we call these in general methods. And look, I say here's a rule of thumb, which is something I already described right here in the comments. You see here I say structs are good to package just the data, and classes are good to package data and methods. Now this is just a rule of thumb. You do not have to follow this by any means, but when you see other C++ code out there, if you have this understanding, it will make a little more sense. So if your object is going to have methods, we should use a class, but if it just has the data, then you can go ahead and use a struct. Now, since member functions belong to the class, they have access to all variables within that class, including private members. And so with this understanding, in general, member functions will always be public and member variables will likely be private. Now this is not always true. You can code classes exactly how you want, but this is the general pattern in which the member functions, which we call methods, will be working with the private variables. And so here I mention, if a member variable is private, how can we make it accessible to the outside scope? Right? Just like I showed you here in this example, where we had compiler errors because I was trying to access these private members, which we're gonna list them as private now. Where I try to access these private members, how can we make them accessible? Well, we have a few options. We can make some read-only private members, in which read-only means we cannot change the value, but we can read from them. We'll use a method called a getter. Now, a getter is just a simple function that returns a copy of the variable. That's all it will do. And so let's make an example of a getter function. Now remember what I said. In general, the variables will be private and the member functions will be public. So underneath this public access modifier, I will type int get x. And within this function, we can type it out just like a normal function. We can return x. Notice that this function is very, very simple. And even though x and y are private, main has access to this function called getX. So notice it will return a copy of x. And so in this way, main can read from this point, but it cannot set values to x and y. So we can make another getter for get y and return y. And now that we have these getters, which are just functions, right? We call these methods. I love repeating myself. Now, when we're down here, I'm not going to set these values yet. We'll come back to this. But instead of just typing x here, which is the private variable, we can actually call this function getX. And when we come over here, we can call this function getY. And so what we should see now is we're going to see this 3, 4 value from the struct, and we're going to actually see a 0, 0 value from this class, right? Because I'm initializing these values to 0, and we're not actually setting any values yet. So that's a getter. And notice here that everything will compile just nicely. Yep, everything works just as expected. And here we can see now that we've got our 0, 0 point right there. So now coming back to our notes, if we want to do some read writing, we can use getters for the reading, and we can use setters for the writing. A setter is just a simple function that will take in a parameter and set the variable equal to the parameter. So it's almost exactly the opposite of the getters, in which we can make some setters. Now you have the option to do this as however you'd like. You could do something like, now in a setter, it doesn't have to return a value necessarily, right? This is just a function. Notice that these are returning integers, but in a setter, we're probably not going to return anything. So it can be a void. And now we could do a set x and a set y, but I'm going to combine both of them and just say we can do a set points value, or a set points method, in which we take in some value I call x1 and some value I call y1. And inside this function I can say, hey, x is equal to x1, and I can say y is equal to y1. So now we have this setter method, which is of public access, so that main has the opportunity, or it has the ability, to call this function and actually control which values are within this class. So we can just call p2 dot set points, and inside here I'll put number 4 and number 7. And so this kind of looks like some stuff we've seen with strings before, right? When you call string.length, or you call vector.size, or you call infile.open, we're calling methods from those classes. And here we're calling setPoints, getX, and getY. So once I save this, it looks like I went somewhere that I shouldn't have. Looks like I pressed Control X or something. We can just pull this function over here into Sally. We compile this code, and we can be on our way. ./a.out. And there you have it. We set those points in there for 7. And so at this point, we've covered kind of the intricacies of public and private members, right? In which private members are accessible to things within the class, such as these functions. But we cannot directly access these private variables from outside of the class. So let me just take a look over here at my notes to see if there's anything else that I wanted to cover before we move on to our next example. And it does look like there's one thing that I would like to talk about, and let's just quickly introduce function overloading right now. And this is all we're going to get for function overloading. It's going to be very simple. And please give me one moment here. I'm just going to slide over to my door and shut it. All right, and we're back. So let's take a look at our notes. And function overloading is all the way at the top. And let's just quickly read what this says. This says functions that have the exact same name, but they have different parameters. That's all it is. The functions need to be within the same scope. So I kind of just listed this small little example here where I would say size is a member function, a method that belongs to the class string, and size is also a method that belongs to the class vector. Notice that these methods have the exact same name, size and size, but we do not consider these as overloads because they belong to different scopes. This size belongs to the string, and this size belongs to the vector. So, as long as the functions belong to the same scope, and they have different parameters, we consider it a function overload. So how do we know which function to call if they have the same name? Well, we just look at the parameters. And here I include an example in which you could just copy-paste this, in which I might just do it, so we can look at it in the nice, pretty format of VS Code. Let me do a Shift Tab over here and bring everything to the left part of our screen. Notice here that these functions are all called add, but they return different types, and they take different parameters. This one is int, this one is int float, this one is float int, and this one is float float. And this one is string string. And so in fact the compiler will know if we come somewhere into main and call add, depending on what types we supply to it, it will know which one of these to call. And so I'm not going to do this example because I would like to combine our kind of class discussion here, in which I will include a function overload within this class point2d. So let's define an extra member function. We're going to call this function print point. And which notice here I'm down here, I'm typing out these cout statements. Let's like package this up into a nice method so we don't have to do this cout statement every time. So I'll come up here, and this is a print function, so we can just call it a void. print point. And within this print point function, we will do exactly this. I'm not gonna do that one since that's a struct, but I will do this one, which is a class. Now this will work just fine. And in fact, you may prefer to do it this way, in which you call getX from within the class. That's completely fine. But recall that print point belongs, it's a member function to this class point2dc. So we can not even call getX, and we can just put X and Y here, because this member function will have access to those private variables. Now let's do an overload on this function. And in an overload, there's only one thing I'm allowed to change, and that's the parameter list. So let's say in this parameter list, I include a character. And instead of printing out these parentheses, I print out the character instead. So notice that these two functions, they have different functionality. They have their own code tied to them, which is necessary in function overloading. Every overload will have its own body of code. But in this print point function, I'll be printing the point with these parentheses. And in this one, I'll be printing it with some character that I pass in as a parameter. And in fact, we can take one step further, overload it one more time, and let's say we do the left one and the right one. Character L, character right. So that will be the left one, and this one will be the right one. And so notice that print point has 3 overloads, in which they all have different parameter lists. And so if I come down here to P2, and I call these functions, I can call print point. And let's see what IntelliSense was going to say there. I'm kind of interested. Notice here that my face is kind of in the way. If I click on this, it says 2 overloads. It says there's 2 overloads for this. That's really cool. I'm kind of glad that it said that. It was a welcome surprise for sure. So we're going to call print point, and print point on P2 multiple times, except this time we're going to do it a few different ways. The first time we'll print it as regular, and the second time we'll pass in this character pipe, a pipe character, and the third time we'll pass in, let's say, a bracket and a bracket. Now the compiler knows which function to call because of the different parameters. Let's go ahead and compile this. Let's run it, and then we'll move on from function overloading into our next example. I need to compile it first, and then I need to call ./a.out. And notice here that here are our 3 function overloading calls. We've got 474747, one with the parentheses, one with the pipes, and one with the brackets. Now, Sally or MobaXterm is what's coloring this a different color, just like it colors the -std up here a different color. I'm not sure why it does that, but that was not the C++ code. So that wraps it up for our first example, and I'm going to save this under a different name. We'll just call this exe1.cpp, and I will put this exact example on WebCampus, even though I provided a similar code to this one already. So now I'm going to gut this code, and we're going to move on into our next example and our next notes. So the next thing that we talk about is static members. Now this is a very, very important thing to consider. And so let's just read about what we've listed here for static members. This is not the same thing as a static variable. So while I come in here and I gut all of this code, I'm going to get rid of this struct because I'm done with those for today. I'm going to get rid of this comment because I'm done with that for today. We'll go ahead and keep our class as it is. And then I'm going to come down here into int main, and I'm just going to show you what a static variable is. When you type x, int x, this is a static variable, in which static means the memory is allocated before runtime. So this is a static variable in the context that you should know, but we're going to call this a static member. So it's a member that belongs to a class. So what does that mean? Here I put this note, static variables, the memory is allocated before runtime. A static member means that there's only one member for the entire class. And so let's go ahead and get started on this. There's a few more things that I note here. One is a static member variable must be initialized in the outer scope of the class. In general, that's the global scope, but it's not required to be in the global scope. And always remember that static member functions, which are just like static member variables, have access to static members, but not regular members. And we'll talk about this. So let's go ahead and come into our code here, and I'm going to kind of clean this up a little bit. I'll show you kind of how I like to do my getters and my setters, because it is taking up a whole lot of lines of code, and I don't like it. So I kind of like to do this horizontal coding method, where I'll just kind of put these tiny little bodies out to the right, and then we've got these nice kind of one-liner methods going on. The print points can be that way as well. I don't see why not. But maybe for these print points, we will just keep them down below. I'm not too picky about it. So we'll bring them there. We'll bring that there. All right, so we've got these horizontal print point functions. And now I'm going to introduce this static thing that we're talking about. So I'm going to introduce a static int. I'm going to call it point count. The static int point count means that this integer, there will only be one of them for the entire class, for all of the objects of that class. Only one of these for whole class. And so here's the thing. When I come down into main and I say, and I'm going to fix up my class here, it's now just going to be called a point2d since we're only working with a class. I'm going to declare a point2d variable. Now this is a static variable. We're going to call it p1. And then if I declare another one somewhere down here, p2, these functions or these variables have their own x and y. Has its own x and y. And so the x within this p1 is different than the x within this p2. Yet the point count is the same for both of them. So that's what it means to be static. And so let's just look at our notes here and see what I've done here in the example. So notice here I've kind of got the same thing going on here, which I made this one public. But I'm going to kind of combine things together here. And I'm going to keep it private, and I'm going to show you how we work with it. So there's only one of these for the whole class, which means we cannot initialize it in here. This is not allowed. And let's also make a static function. Let's go ahead and make a getter function. And let's call it a static method, static int get point count. And all we have to do is return the point count. Notice that this is still a member variable and it is private. So we do have access to it within these methods, but we just have to treat it like there's only one of them. Now, this get point count is going to be static as well, because we only need one of these methods for all of the classes. In a sense, these print point classes, and in fact, if I made this static, I will show you that the code will not compile. So let's actually go do that now, in which I make this print point function static, and I'll show you why the compiler doesn't like that. We'll also look at what the error says, so you can learn to recognize these errors for yourself. It did compile though. Oh, oops, I overwrote example 1. Of course I did that. Don't worry, I'll repair it in the after hours. I'll repair it in the after hours and upload it to Web Campus. So please don't fret. Let me bring in this new file that I'm talking about. And I really hope it shows me a compiler error. Otherwise, I'll look silly for this YouTube video. And there you have it. It says invalid use of member point2dx in a static member function. Now, why is that? Well, since there's only one print point for all classes, which x is it referencing, right? If you come down here in main, we've got a P1 and we've got a P2. And they each have their own x. So we know that there's two x's somewhere in the environment. But this print point doesn't know which one, because we said it's a static function, which means there's only one function. And so this function has to be non-static, because it's going to be playing with these non-static members. But this static int get point count is 100% allowed to be accessing, or to be accessed at least within, let me re-say that. This static member function is allowed to access static member variables. So that's how static things work. How do we call static members? Well, before we do that, I'm going to introduce you to one more thing. I'm going to pull my notes over here just because we might be kind of going out of order here, and I just want to follow along with the notes. The first thing that we have to do actually is I have to initialize this value. So I'm going to show you how to initialize it. There's only one way to do this. We must use something called the scope resolution operator. Now we'll come to that in our very next example, which we may be covering on Monday on the Twitch stream, depending on how far I get today. It does look like we're about 45 minutes into this YouTube video, so we may very well get to it. But if you come down here, you will see this section called declaring member functions. And you'll see here it says outside of class, you will need to use the scope resolution operator. And so I'll just introduce that to you now really quickly. And in fact, if we come to this error screen, you'll notice here that it says point2d, and then you see this : thing going on. This is the scope resolution operator as well. So we've already seen it. So let's learn what it is. So this point count belongs within a certain scope. The scope is the point2d, right? In between this bracket and in between this bracket down here. And so in order to access this scope, we use the scope resolution operator. So what we say here is we say something like point2d, and then we gotta type : and you'll notice this changes colors very nicely. And now we have the ability to access things within this scope. Now, if I type something like y, it's not going to be happy because it's going to say, which y? This doesn't make sense. Which y are you talking about? Is it P1's y or is it P2's y? But we can access the static members. So let's go ahead and access the point count. There you go. We're going to say it's equal to 0. Now there's one more thing we have to do. We have to specify that this is an int. And to be honest with you, I'm not sure why that's required in C++. But it is required for declaring or defining the member functions or the methods. And so this is just kind of like, I guess, a definition of what this point count is. And so you must re-specify the type, but this is where you initialize it. So that's good. Notice that we don't have to put static here. In fact, if you put static again, the compiler will yell at you. So let's not do that, and let's just leave it as that. And now, if I wanted to call this from main, I use the scope resolution operator again, so I can just come over here and copy this. So using scope resolution, I can get the point count. And we're kind of typing behind my face here a little bit, so let me move that. And so if I want to access this static member function, right, because remember that this is a private member. Notice that it's underneath this private member access specifier. So directly from main, I cannot say something like point2d point count. It's very obnoxious, this thing popping up. This will complain the same private error that we've been discussing before, but we can't access this get point count. So I'll go ahead and do that. And notice that this is an integer. It's going to be returning an integer. So I can say something like cout. Or I can say something rather like int pc is equal to point2d get point count. And then I can print it. I can say, hey, there are PC, not for politically correct, but for point count, points. Now notice, we're not going to be incrementing this yet, and we'll do that next, but I will show you that this code compiles, and that it will say that there are 0 points. So if I compile that, and ./a.out, it'll say there are 0 points. And that's because we haven't done anything with the code yet. But this static member function does exist, and this static member variable does exist. So let's move on now to our next section here in the notes, in which we're actually just going to talk about constant real quick. So we just talked about static members here, and now we're going to talk about const members. And not just any constant member, but a const member function. This one's really easy. Member functions with a const are not allowed to alter the object in any way. And this is important as well. A static member function cannot be constant because there's only one of them. So it's not going to be altering any objects anyway. So let's just kind of talk about what this means. And let's kind of identify some functions in here that alter our object and functions that don't alter our object. So let's go ahead and look at our getter methods. Now notice that these just return x. Nowhere in this function does it say x is equal to 5. These just return some value, and they do not change these variables at all in any way. And so in fact, this function should be a constant function. Just like this one. So that's what it means. Should be const, not altering our object. Right? They're not changing it anyway. Now static get point count, let's come look at the notes. Static member functions cannot be const. So let's just skip over that one. Now let's look at this void set points. notice that it looks like we're altering our object in some kind of way. It looks like this X is getting changed, and it does look like this Y is getting changed as well. So in this sense, if I type const here, the compiler will yell at me, and the compiler will say, hey, that's not correct. It looks like this function's doing something to our object. So that guy's not going to be constant. But these print points, none of them are altering our object at all. So these are all going to be constant functions. Constant, constant, constant. Now it does look like we're kind of losing our bodies here, so we'll just do that. I know I'm changing my mind here just a little bit, but we're just trying to keep things nice. So that's all constant is. And so now that we've covered that, we can finally move on to a constructor. And we can begin running the code for this example. So a constructor is kind of like a function, except that it is only called when an object is created. And when an object is created, it's either declared as a static variable, right? So if I come here and look in my int main, we have two static variables here because their memory is allocated before the runtime. And I didn't want to go there. And I say or allocated dynamically. Now, we have not covered dynamic allocation yet, so I just want this to be in the notes. But if you don't know what that is, don't worry, because that's coming up next in the future weeks. I will also mention up here, I mentioned protected members. I say this is for next week, so we'll talk about what a protected member is as well. So there's a few kind of points like that in these notes that we're just kind of skipping over for now. And then let's look at some of our notes. Classes can have multiple constructors. And you can specify a constructor by using parameters. You can specify different constructors by using parameters. This is exactly like function overloading, like we talked about. You can also make it have no constructors. In this case, there are no constructors in this class right now, and this code compiles just fine. But there is a default constructor that G++, when your code is compiled, a default constructor is put in place for this point2d. So just because we didn't specify it doesn't mean there's one that doesn't exist. So what does a constructor do? In general, it initializes our member variables. And the last thing we talk about here is constructors. They have the same name as the class. So let's learn what a constructor is and how to use it. So it's like a function. It should probably be public. And what did I say first? I said that it has the same name as the class. It also doesn't have a type. Let me go ahead and put that in here. It does not have a type. So when you're looking in your classes, the constructors will look like this, in which you see point2d, and then we've got these two little parentheses, and then you see some body. Now let's go ahead and put some things here. Let's say cout, and let's just say default constructor being called. Now, what does this constructor do? Well, it initializes the variables. So notice here that I'm kind of doing this initialization thing up here. That's not necessary anymore. Since we have a constructor, we can initialize them in here. We can say x equals 0 and y equals 0. Now there's an easier way to do this. I will introduce it when we do our next constructor, but let me just show you when this function is being called. So now we're going to go ahead and do some compilation down here. Notice here it says point P1. I'm going to see out something funny here, like print statement. just like that. And then notice that I declare point P2 right after this print statement. And so when did I say a constructor will be called? Well, if we come look in the notes, it says it is only called when an object is created. So we should see default constructor called for point P1 first. And then we're going to see print statement. And then we'll see that the default constructor was called again for point P2. So let's compile that code and let me show you that that's how it works. So I'm going to pull this over here. We'll compile our code here. We're going to ./a.out. And look, it's exactly as I said. Here we say default constructor was called. Then we've got a print statement. And then we call default constructor again. So notice that whenever the constructor is called, it's when we're declaring these objects. And if you ever have trouble with that, you just have to put a print statement in this constructor. Now, let's make another constructor, and let's add a few things. So the first thing I want to add is, hey, if we created a constructor for this object, we can probably increment the point count. Right? I'll say point count plus plus here. Now, because there's only one of these, we can access it within non-static members of a class. Because there's only one of them, we just have to be aware that there's only one of them. And whenever we construct a point, we probably want to increase the number of points in our program. So I'm going to make another one. And this one, we're going to just change it up ever so slightly. It's going to be point2d here. And notice that this point2d is almost identical to this one. We need to take kind of a function overloading standpoint from this, in which we need to pass in some parameters. So let's say I've got int x1 and I've got int y1. So this constructor requires some parameters. And all I'm going to do is initialize these values. I'm going to initialize x and y using these parameters in the constructor. Now, I could do it just like this, right? I could say x equals x1, y equals y1. But I'm going to show you the inline method. When we come to inheritance, I will require you to use inline method for some things. In this case, if you would prefer to do it this way, or if you would prefer to do it this way, I don't mind either. So if I want to initialize variable x, I just have to type this colon sign after the function. And then I'll put my x here. And then whatever I'm initializing it to, I'll put within these parentheses. And then I can just kind of go down the list and do the same for y, y1. So what this will do is when this constructor is called, it will initialize x to x1 and y to y1. It looks exactly like this. It's just a different way of doing it. And now we're going to do this exact same thing that I'm doing here. Except this is going to be the parameter constructor. Parameter constructor called. So I will come down into main and I'll show you how we can use this constructor. And I want you guys to know that you can do this with strings as well. So just to kind of take a step back, if we do string s equals this, we're calling a string constructor that takes in a string parameter. Well, in fact, we're using an operator overload there, so I'm not going to, well, I'm not going to touch on this at this moment, but this actually might be taking in a character array. But let's not touch on that right now until we get to operator overloading and things like that. But when we call the default string constructor, that's when we do something like this. if we want to initialize string S1 to be something like beans, then we're calling a string constructor that takes in an array of characters. So hopefully that makes sense, and we can do this exactly the same way. I just want to put constructor here for those of us who look at this code later. If we want to do this with our points, very easy for us to do that. All we have to do is say something like point p2, and then let's pass in whatever values we want, like a parameter. So just like that, we pass in 3, 4, and we call in the second constructor of this. And so what we should see now is one default constructor called and one parameter constructor called for our code. So let's go ahead and pull over our example into Sally. We'll go ahead and G++ that. And we're ./a.out, but before I do that, I would just like to remind you that we're using this static method down here in main, right? And notice within these constructors, I increment the point count. Now, we probably saw that already the last time I ran this code, but I just wanted to point it out. In which P1 was created with a default constructor, and then we did our print statement, and then we declared point P2, and notice that we called it with the parameter constructor, not the default constructor. And look, there's 2 points. Because in each constructor, we incremented our point count. So just like that, we've got this nice little class here for 2D geometric points, in which we kind of store these private members X and Y, and we keep track of how many there are in the program. We've included 2 constructors for this class. One is a default, which initializes these values to 0. And one is a parameter constructor, which initializes these values to the parameters that are passed in. In addition to that, we've got some getter methods. Recall that these getter methods are constant because they are not altering our object in any way. We also have a static getPointCount method, which just returns this static member variable. And the way we call this function is by using the scope resolution operator. We could also do it this way, just to show you guys that this is totally fine as well. Since there's only one of them, this makes sense, right? It's kind of like a many-to-one relationship in which no matter what point we have, if we call getPointCount, we know which one we're talking about. So this one will work just as easy, though I would prefer you to do this method because it makes more sense in that we know that this is a static member function. And that this here kind of looks like just a regular member function. We talked about our setters and our getters, right? And then we also talked a little bit about function overloading going on here. These guys are constant, remember, because they are not altering our object in any way. We initialize these static members outside of the class. So this is actually in the global scope here. And then in main, we just kind of declared some objects. We showed that these constructors are being called somehow and in a specific order. And that's really all we did for this program. Let me just kind of come back through the notes here to make sure that we got it. Yeah, we did talk about that. We did talk about our static members. We talked about our constant member functions. We talked about our constructors. And what's next up on the list? Well, it's destructors. Now, we've only got a few minutes left, about 10. So I will save this actually for next class, in which we'll wrap up classes and we'll move on into our next thing. We will also be discussing assignment 2 next class. So come prepared for that. Please do your assignment. Thank you for watching this video. I'm sorry that we had stream problems. and I'll see you guys in the next one.